So we are going to discuss about the application of the conservation of linear momentum. So that linear momentum can be applied when the net force on the particle is equal to 0, and for that situation we will use that concept, that is Pi equal to P final. So initial momentum equal to final momentum, and there are separate application for that. So starting with that, let us say this is a simple type of situation where there are two balls are moving, mass of 10 kg and 20 kg. They are moving with velocity 4 meter per second, and another one is 1 meter per second. Now you are asked to check whether if the bodies are collide. So these two bodies will collide with each other. Why? Because the particle number 10 kg is moving with a higher speed. So ultimately the red particle collide with the blue particle, and you are asked to calculate what is the final common velocity when these both will stick together. Okay, so ultimately what happens, this is the initial situation, and finally both red and blue ball are sticking together and they are moving with the combined velocity, let us say V naught. Okay, and in the entire situation, net force acting on the particle system just before and just after collision is 0. Why? Because whenever the red ball is in contact with the blue ball, so on the red ball there is a force acting in this direction. Okay, similarly on the blue ball there is a force acting on the other direction. So these two forces, if I say these are the reaction forces acting on the both the balls, so they will cancel each other. So that means I can say that net force acting on the system is 0. So I can use the conservation of linear momentum. So initially 10 kg is moving with 4 meter per second, initial momentum for 10 kg, and 20 kg is moving with 1 meter per second, so 20 into 1. And that should be equal to sum of the momentum, that is the final momentum. So that in final situation, both 10 kg and 20 kg stick together. So that means total mass of the system becomes 10 plus 20 is 30 into V naught. Okay, so that should be equal to 30 V naught. So it is 40 plus 20, that means 60. So V naught becomes 2 meter per second. And since I am getting the positive number, that means the particle are moving towards the right, because I have said that V naught is positive, and that's why I am taking this. So 2 meter per second towards the right will be your answer. Okay. So this is one of the applications where we apply the conservation of linear momentum during collision. So that will be our next topic when we study the effect of collision. Now this is the idea that whenever there are two particles that are colliding with each other, that means the net force acting on those particle system is 0, and for that reason I can apply the conservation of linear momentum. Now moving on to the next situation, let us say there is a man whose mass is given as 5 kg. Okay, and there is a balloon is there 15 kg. Now they are kept in a gravity-free space. What is the meaning of gravity-free space? Means there is no net force acting on this. Why? Because there is no mg. Okay, mg part is 0. So there is no g. So yes, there is no g. That means the mg part is not there. Okay, that means what you can say, that along the y direction the net force is 0. So along the y direction I can apply the conservation of linear momentum. Now you are asked to calculate the velocity of the balloon if the man starts climbing the balloon with a velocity of 10 meter per second with respect to balloon. Let us say the man is moving with a velocity u, and at that point the balloon is also moving upward, let us say, with a velocity v. Okay, so what is u? U is nothing but the velocity of man with respect to balloon. So this v, man with v. So that means u equals to what is vmv. So that should be equals to velocity of man minus velocity of balloon. Now I have to take in ground reference frame. So velocity of man should be how much? Velocity of man should be equals to u plus vv. Now Vv is assumed to be V number, so it should be equal to U plus V. Okay, so that is the velocity of man with respect to ground. So this is the velocity of man with respect to ground reference frame. Now if I apply the conservation of linear momentum along the y direction, so initial momentum for the 5 kg mass should be equal to 5 into U plus V, and the momentum for the balloon should be equal to 15 into V. That is the final momentum. And that should be called initial momentum. And what is the initial momentum? Initially the system is at rest. So that number should be equal to 0. Okay. So what I am getting, that 5u plus 5v plus 15v should be equal to 0. So that means 20v equals to minus 5u. So u is given as 10 meter per second. Okay, u is given as 10 meter per second. So 20 into 10. No, sorry, not u. U is given as 20 into V, right? 20V should be equals to 20V equals to 5V. Yeah. This is 20V equals to minus 5U, and U is given as 10 meter per second, so minus 50. So V becomes minus 50 by 20, that is minus 2.5. Downward. So 2.5 meter per second down. So that means whenever the man is moving upward, the balloon is moving the downward phase. Okay. So this velocity that is given with respect to balloon. So every time whenever I do the momentum conservation, you have to take care about the velocities that are to be in the ground reference frame. So that's why I have converted this number Vm. Okay. Now let us say there is the explosion of bomb. So there is a bomb of mass capital M is placed at the origin, explodes into three pieces, each of mass m by 3. Out of these three masses, the two masses move along x-axis. Let us say this is moving along the x-axis and this is moving along the y-axis. Okay. One is moving along the x-axis with a velocity of 3 meter per second, and that is moving along the y-axis, is moving along the y with a velocity of 4 meter per second. Now you are asked to calculate the velocity and speed of the third mass. So in this situation, initially the bomb is at rest condition. Initial momentum is 0. Because whenever the explosion takes place, total internal force becomes 0. So I can take the momentum to be conserved. So let us say the m by 3 mass is moving with a velocity with a v vector. Okay. So initial momentum is 0. So final momentum is also equal to 0. So the mass which is moving along the x direction should be the momentum m by 3 into 3I. The mass which is moving along the y-axis should be momentum m by 3 into 4j. And the mass which is moving with the velocity v vector, that should have the momentum m by 3 into v vector. That number should be equal to 0. That means I am getting v vector should be equal to minus 3I minus 4j. Okay. So this is the velocity vector of the third mass. So it should move along this direction. So first mass is moving along x, second mass is moving along the y, so third mass has to move along this direction. Okay. So this is the final velocity vector of the third mass. So your answer should be minus 3I minus. Now you are also asked to calculate what is the speed of the third mass. So speed means nothing but the mod part. That is 5. Okay, v vector mod is equals to 5 meter per second. That will be your answer there. Okay, so minus 3I minus 4j and 5 meter per second. That is option B is the correct one. Okay. Now moving on to the next. Let us say there is a body of mass 50 kg, 30 kg mass is thrown from this point at an angle of 53 degrees with a velocity of 50 meter per second. At the topmost point, once the particle reaches at the topmost point, it breaks into three parts, each of mass 10 kg. So initially the mass is 30 kg. Once it breaks into three parts, so all the three parts are equal. Let us say this is the first part, the part number 1. Let us say there is another part, part number 2, and another part is the part number 3. Let us say there is the part number 3. So each are having the mass of 10 kg. Now it is given that the one mass retraces its path. So let us say red color particle retraces its path. So it has a velocity in that direction. So ultimately the particle will come back to the initial position. Okay. Now regarding the second mass comes to rest. Let us say the green particle comes to rest. So the velocity of this green becomes 0. And you are asked to calculate the final velocity of the third mass. That means the velocity of the blue. So let us say this is the v vector. Okay. Now how to calculate that? So on reaching the topmost position, just before explosion, the ball is moving with a velocity of only ux. So at the top of the projectile, so velocity is only along the x direction, no uy. So what is the ux number? That is 50 cos 53. Okay. So that is 50 into 3 by 5, that is 30. So 30 meter per second is the speed of the ball just before the explosion. So what is the initial momentum? So initial momentum should be equals to 30 into 30 along the x direction. It is along the x direction. Why? Because the initial velocity is along the x direction. So initial momentum is along x. So final momentum should also be along the x. Okay. So red ball has to move along the opposite direction so that the particle will come back to the initial position. That means the red ball should have the velocity of 30. Otherwise, it cannot press back. Okay. Why? Because the entire ball having the velocity which is ux, that is 30 just before explosion. After explosion, the red should get the same 30 value so that it will retrace the path. Regarding the V vector, so V should be blue colored ball should move along the positive x direction so that the momentum can be balanced. So final momentum, what I can write? Final momentum should be equal to, for the red mass, it should be equal to minus 10 into 30. Why? Because this particle is moving in the negative direction. And the blue particle, that 10 should be multiplied with the V, and that gives the value as 30. Total 900. Total momentum. So ultimately what I'm getting, 10V should be equals to 900 plus 600 in 1500. Okay. 900 plus 300, sorry, 120. 1200. 900 plus 300 means 1200. 1200. So ultimately V I am getting, that is 120 meter per second. So that means the blue colored particle should move with a speed of 120 meter per second so that it will momentum can be balanced. So initial momentum is along x direction. So final momentum should be also along the x direction. That's why I am taking the V should be along the x direction. Okay, it should not be inclined. Now, so this is the trolley problem that we have already discussed. So let us do some kind of application over here. So there is a mass of man is given a small m standing on a trolley of mass capital M. So initial situation, both are at rest. So initial momentum is 0. Okay. And the man walks on the trolley with a velocity v naught with respect to trolley, then the velocity of the trolley should be So if the man is moving with respect to trolley with the speed of v naught, and at that point of time later the trolley is also moving with the speed of u. So v naught number is given as the velocity of man with respect to trolley. That should be equal to velocity of man minus velocity of trolley. Now velocity of trolley is how much? That is u. So what is the Vm value? That is the velocity of man with respect to ground reference point should be equal to v naught plus q number. Okay. So I can do the momentum conservation between the initial and the final situation. The initial momentum is 0. So what is the final momentum? Final momentum should be equal to momentum m into v naught. So v naught plus u is the momentum for the man plus capital M into u should be the momentum for the trolley. So that should be equal to our 0 number. So from that what I am getting, u small m plus capital M should be equal to minus m into v naught. That means u is equals to minus m v naught divided by capital M plus small m. That means negative sign signifies that if the man is moving towards right, the trolley has to move towards left. So u is negative means trolley is moving towards left. The answer is the second one, m v naught divided by capital M plus small m. But it is towards left. If I say the man is moving towards right, then the trolley has to move towards left. Okay, so second one was the answer. Now the same situation over here. Now initially the man and trolley is moving some speed u. Okay, and again the man starts to move with the velocity v naught. So he is moving with the velocity v naught, and at that point, let us say trolley is moving with the velocity v. So that v naught number is given as the velocity of man with respect to trolley. That is equal to vm minus vt. That is equal to vm minus v number. So what is the vm number? That should be equal to v naught plus. Okay. So final momentum should be equal to small m into v naught plus v. That is the momentum with respect to ground plus capital M into v. Is the final momentum. And what was the initial momentum? Initially, the system is not at rest. Initially, entire system is moving with the velocity u. So, initial momentum should be equal to small m plus capital M into u. So, now equate these two numbers. So, once I equate these two numbers, so I will get the value of v number. So, small m plus capital M into u should be equal to small m into v naught plus v plus capital M into v. So, take v common. So, m plus capital M plus m into v naught. So from that, I am getting the value of v should be equal to m plus capital M into u minus m into v naught whole divided by capital M plus small m. Okay. So this was the answer. So if you compare, none of the answer is correct. No. But I will take the option A. Why? Because after moving the part the man, I can say that if V is negative, then only the answer one will be correct one. Okay. So that means according to the given value, opposite direction. That means trolley is moving towards left direction. Okay. See, negative sign. So once you put the negative sign, then the answer will be V should be equals to M into V naught minus small m plus capital M into Q divided by M plus M. That will be your answer. Okay. So it depends on the numerical value that is given. I cannot comment whether this V number is positive or negative. Okay. But for the options given, so I should pick the option number A. Why? Because the option number A is just the negative of the value that I have got. Why? Because as per the value given, let us say the small m value, capital M values all are given. So you can calculate the number. So once you got the number, that number comes to as a negative one. That's why you have taken the negative answer. Okay, that means the trolley is moving towards left. Now, so the man is standing on a trolley of mass M and length L, which is placed on a smooth surface. If the man walks on trolley and reaches the other end, then find the displacement of the man on the trolley. So initially the momentum is 0. For this system, initial momentum is 0. And also the net force is 0. Okay, initial momentum is 0, net force is 0. That means what you can say, the center of mass is at rest. Center of mass is at rest. That means what you can say, that m1 into x1 or delta x1 plus m2 into delta x2, that is equals to 0. That is the concept that I have already given, that whenever the center of mass is at rest, you can apply this concept. That is delta x1 is what? Displacement of m1 mass. Delta x2 is what? Delta x2 is the displacement of m2 mass. Here, once the man is moving in this direction, so trolley will move in the opposite direction. Let us say the displacement of the trolley is by x. X is the displacement of the trolley. And because of the displacement of the trolley, the man has to move by a distance of L minus x. Why? Because the trolley is moving in the opposite direction, man is moving in the forward direction. So displacement of the man is M into L minus x plus capital M into minus x. Why minus x? Because if I take L minus x as positive number, then x will be the negative number. Okay. So displacement is minus x. So ultimately what I am getting, that small m into L should be equals to capital M plus small m into x. So what is x? X is equals to small m L divided by capital M plus small m. So that is the displacement of the trolley. Now regarding the displacement of the man, so man is displaced by a length of L minus x. So that means L minus small m L divided by capital M plus small m. That means I am getting capital M L divided by M plus M. So this is the displacement of the man and that is the displacement of the trolley. Okay. So man is capital M. So option number B is the correct one. Okay. So both are displacing. So while the man is moving in the forward direction, so trolley is moving in the backward direction. And in the entire situation, initial momentum is 0. So I can say that the center of mass is at rest. So I can use this concept. So this is the concept that I am using over here. So m1 into delta x1 plus m2 into delta x2 will be positive. Okay. Now, so far we have applied only the concept of conservation momentum. Now we can apply the conservation momentum along with the energy balance to solve this kind of problem. So there is a mass of 2m and there is a mass of m. So block of mass m is released from the rest. So from here it will be released. From the top of the circular cut as shown in the figure, find velocity of both the blocks once they are just leaving each other. That means after some point of time, the small m comes over here. Let us say the small m is moving in this direction with velocity v1, and at that point of time, the 2m is moving in the opposite direction with velocity v2. Okay, because this is resting on the smooth floor, so no friction is acting over here. That means what you can say, the net force is 0. So whatever the force is 0, that is only along the x direction. No net force is 0 along the y direction. Net force is there along the y direction. So conservation momentum can be done along the x direction only. So for the momentum balance, what you can write, m into v1 minus 2m into v2 should be equals to 0. That means what you can write, v1 should be equals to 2 v2. So that is the first equation. But there are two unknowns. So second equation has to be obtained by the energy conservation. So once the small m particle dropped by this r distance, so this is also r. Okay, so potential energy is dropped. So loss in potential energy is basically equals to gain in kinetic energy. Gain in kinetic energy. So what is the drop in potential energy? So drop in potential energy is observed for the small m particle. So that is mgh, so mg into r. That should be equal to gain in kinetic energy. So kinetic energy is gained by both the particles. one particle having the energy of half m v1 square, another particle having the energy of half into 2m into v2 square. Okay. So this is the second equation. The solution of this 1 and 2 will give the value of v1 and v2 separate. Okay. So from the second equation, multiply both sides by 2. So what I am getting that 2gr should be equals to v1 square plus 2v2 square. Okay. Now v1 equals to 2v2. So here I am writing 2v2 whole square plus 2v2 square. So it is getting the 4 plus 2 means 6v2 square. So 6v2 square equals 2gr. So v2 square should be equals to gr by 3. Or v2 should be equals to under root of gr by 2. So this is the velocity of the 2m mass. Now correspondingly, what is the velocity of m mass? M should be equals to v1, that is equals to 2 times of v2, that is 2 times of gr by 3. So these are the two answers. So one answer is gr by 3, another is 2 gr by 3, that is the A option. Okay. So in this situation, I have to apply both the conservation of linear momentum and also the conservation of energy also. And while we apply the conservation of linear momentum, I am applying only along the x direction. Along x. Why? The net force is 0 along x. But along y, the net force is not equal to 0. Okay. Now there is the problem on the spring. So let us say in this situation, spring is compressed by x naught distance. Okay. Yes. So in this situation, there is a spring which is compressed by a distance of x naught, and you tied these two blocks with a string. Okay. So once you cut the string, you are asked to calculate the speed of both the blocks. Okay. So initially the spring is compressed by x naught length. So once you cut the string, so both the blocks will try to move in the opposite direction with the speed of velocity v. Okay, because mass is same, so both the blocks will attain the same speed. So initially there is only the potential energy. So what is the potential energy? Potential energy is half k into x naught square, and that should be equal to the final kinetic energy. So what is the kinetic energy? One is half m v square, another is half m v square. So half m v square multiplied by 2. So what I am getting, k x naught square equals to 2 m into v square, or v square should be equals to k x naught square by 2m. So v should be equals to under root of k x naught square by 2m, or x naught into under root of k by 2m. Okay, so that is the speed of individual block. Once you cut the string, both the blocks will try to move in the opposite direction with the velocity v. Okay, so answer is option number B, that is k by 2m under root into x. Okay. Now this is another type of problem where there are two blocks are there. One block is moving the velocity v naught. They are attached to the spring. So initially the spring is under relaxed state. So once you start to move the block, let us say I give the naming. Let us say this is the A block, this is the B block. You are pulling the B block. So once you are pulling the B block, so the spring force that is acting on the B block will be in this direction, in the kx force. Okay. So this force will try to reduce the velocity of the B. Okay. Similarly, the kx force is acting in this direction also. So this will try to increase the velocity of the A block. Initially, the A block has 0 velocity. So from 0, it will try to increase the speed. Why? Because now this kx force is providing some kind of acceleration to the block A. But for the block B, kx is producing some kind of retardation. That's why the velocity will reduce. So because of that, ultimately the spring length will change, and you are asked to calculate the maximum elongation. So when the maximum elongation takes place, so after some point of time, what you will observe that, so both the blocks are there. Let us say this is the block B, and this is, let us say this is the block A. Now they are connected with the spring, and once they are moving the same speed, let us say it is also moving with V, that is also moving with V, then only I can say the spring is in maximum elongation. After that, what happens? There is a further increase in the velocity of A. So once the velocity of A will increase, and the decreasing velocity of B takes place, and then the compression will start. Okay, until and unless there is a maximum compression. So this is a situation where the maximum elongation takes place. So for maximum elongation, the speed of both the blocks should be same. Now initially, what you can say, if I take both the blocks and the spring together as a system, so net force on the system is 0. Net force on the system is 0. So kx and kx will cancel out. So initial momentum is how much? Initial momentum should be equal to only a into v naught, because only one block is moving with velocity v naught. And what is the final? P final should be equal to 2m into v, because now both the blocks are moving with velocity v. So 2m into v. So m into v naught should be equal to 2m into v. So from that, what I'm getting, that v number should be equal to v naught by 2. So v naught by 2 will be the velocity of the final velocity of the both the block. So now we do the energy equation. So initially only the kinetic energy is there of the block V. So initial kinetic energy, initial potential energy plus initial kinetic energy should be equals to U final plus K final. Okay. What is the initial potential energy? That is 0. Spring is in relaxed condition. So what is the kinetic energy? Kinetic energy is equal to half m into V naught square. Potential energy. Now the spring is being extended, maximum elongation, let us say x. So half k into x square, that is the elongation, that is the spring potential. In kinetic energy, both the blocks are moving velocity v, so half m v square multiplied by 2. Okay, so I can cancel half from all the side. So m into v naught square should be equal to k into x square plus 2m into v square. Now what is v? V is equal to v naught by 2. So I can use that. So kx square plus 2m into v naught square by 4. That means it becomes half m v naught square. So ultimately what I am getting, kx square should be equal to m v naught square minus m v naught square by 2. That is m v naught square by 2. Okay. So from that I am getting the value of x square should be equal to m v naught square by 2k, or x should be equal to under root of m by 2k into v. Okay. So that will be your answer. So this is the maximum compression. So in this particular analysis, so whenever you are asked to calculate the maximum elongation, so for that situation, so both the blocks should move with the same speed. Until and unless you are getting the same speed of the both the block, that means you cannot say the spring is in the maximum elongation situation. Okay. Now it may be possible that now in this situation, the same question is there. Only thing is that now the both A and B have some kind of initial momentum. Okay. Again, the net force on this kx, and here the kx will cancel out. So net force is 0. Okay. So at the final situation, I know that both the block, let us say this is the A block and this is the connected with the B block. So both A and B should move with the same speed. Both A and B should move with the same speed. Let us say let us move with B. This is also moving with B. So now we can write the initial momentum. What is the initial momentum? Initial momentum is equals to 2m is moving towards right, so that is 4m v naught. And another m is moving towards left, so minus m v naught. That is 3m v naught. So 3m v naught is the initial momentum. And final momentum is equals to how much? Both are moving towards right, so 2m into v is the mass of 2m, and this is mass of m, so that plus m into v, that is 3m v. So this 3m v should be equals to 3m v naught. That means what you can conclude, that v should be equals to v. Okay, that is the final velocity. So finally, both the blocks should move with the v naught towards right, so that I can get the final elongation, which is the maximum. Now do the energy balance between point 1 and 2. So initially, there is a kinetic energy. So one kinetic energy is equal to half m into v naught square, and another is half into 2m into 2 v naught whole square. That is the initial kinetic energy. That should be equal to final kinetic energy. Finally, both the blocks, that is m plus 2m, is moving with the velocity v square plus half into k into x square. Okay. So once we do the simplification, so that number, so if I cancel all the half number, and ultimately this is m v naught square plus 2m into 4 means 4 into 8m v naught square. That should be equal to 3m v square plus k into x square. Now what is v? V is nothing but the v naught square. So here I am getting 9m v naught square, and that should be equal to 3m v naught square plus kx square. So it gives kx square is equal to 6m v naught square. Okay. X becomes how much? 6m by k under root into v naught. Okay. So that is the final elongation. That is the maximum elongation. So option number C is the correct one. Okay. So you have to write the momentum balance in proper way, with proper sign, because one block is moving towards right, another block is moving towards left. So momentum has to be balanced properly. Now let us say this is another type of problem where there is a mass is hanging from the ceiling with a cord of length L, whose mass is capital M. Now the bullet is being fired, which is moving with the velocity U. Okay. Now, once the bullet strikes the capital M, it will embed inside the block. That means that after that, the bullet is within the blocks. Now, after the bullet embeds inside this capital M mark, let us say they are moving with a velocity V naught. Now, you are asked to calculate what height of the block will rise. So, ultimately, it will give the initial velocity. So, ultimately, it will perform a vertical circular motion and it goes up to this point. Let us say this is the final position. So, you are asked to calculate this H number. What is H number? Okay. So just before collision and just after collision for this particular situation, I can do the inert momentum conservation. So initial momentum of the bullet is only there, M into U. There is no momentum for the capital M. So finally, both M plus M is moving with the velocity V naught. So from that I am getting the value of V naught should be equal to small m by capital M plus small m into U. So this is the velocity after the bullet hits the capital M. So now both are moving with this particular velocity. Now, because of that, there will kinetic energy. So at this maximum position, the kinetic energy will be 0. Here the kinetic energy will be equals to how much? That's equal to half capital M plus small m into V naught square. And for V naught square, I can write m divided by capital M plus small m whole square into U square. So ultimately, I am getting that m square divided by 2 into capital M plus small m into U square. That is the initial kinetic energy. So there is a drop in kinetic energy. So loss in kinetic energy is nothing but the gain in potential energy. Okay. So loss in kinetic energy, that should be equal to our gain in potential. So potential energy gain is how much? That should be equal to mgh. So m plus m g into h. Okay. And loss in kinetic energy is equal to m square divided by capital M plus small m divided by 2 into U square. So from that H number should be equal to how much? M square divided by 2 times of capital M plus small m whole square. And divided by G also. G is there. Okay. So that is your answer. So that multiplied by U square. Okay. So option number C is the correct. No. C is the correct one. So this is the height attained by the bullet and block system. Once the bullet will hit the block, then the both capital M and small m are moving with the speed V naught, and with that speed they will rise to the height of H, and you can calculate that height. Okay. Now there is another situation. Now the system, so there is a bead. So this is the bead part. Now when the string is being released and once it becomes vertical, so after some point of time, once you release the red ball, the red ball will be vertically hang like this way. So at this position, let us say the small m is moving with this direction to velocity v, and the 2m that is just above of it is also moving with the velocity some. 2m is moving with velocity v. Okay. So you are asked to calculate the velocity of the bead. Okay, velocity of the bead. So let us say this is the v1 value, this is the value v2. So again, the momentum is being conserved at the h direction. So what is the final one? Initially momentum is 0. Initial momentum is 0 because entire bead block system is at rest. So finally, 2m is moving with the velocity v1. So 2m into v1 minus m into v2 should be equal to 0. So I am getting v2 number should be equal to 2 times of v1. Okay. So this is the first equation. Now again you have to apply the energy conservation. So for energy conservation, so if I take, this is our reference line. So from reference line, so there is a small m mass is dropped by h. So what is h? That is 30 meters. So the potential is dropped, and that potential is increasing the kinetic. So drop in potential and drop in potential energy. What is the drop in potential? That is mgh. That should be equal to gain in kinetic. Gain in kinetic energy. So small m mass is dropped by a height of L, mgl. That should be equal to gain in kinetic energy. So one mass half m is moving with velocity v2 square, another mass 2m is moving with velocity v1 square, and you are asked to calculate the velocity of bead, that is v1. Now what is V2? V2 is 2V1. If I simplify it, so multiply both sides by half, so it becomes 2 times of GL should be equals to V2 square plus 2V1 square. Now what is V2? V2 square is 4V1 square. That means 4V1 square plus 2V1 square. That means 6V1 square is 2GL. So V1 becomes, V1 is GL by 3 root. Okay. Now G is 10, L is 30, here by 3 root. So that means 10 meter per second. So velocity of the bead will be 10 meter per second towards right. So bead is moving towards right, ball is moving towards left. Now what is the V2? V2 should be 20 meter per second once the string is on vertical. Okay. So these are the some typical example where you are applying the conservation of momentum along with the conservation of energy. Understood?